Hello, everyone. Today I'll be talking and discussing a dewatering incident in British Columbia, in Canada. So, next slide. So, the dewatering incident. So, a worker was standing next to a steel caisson and was pulled down and trapped when a quicksand condition was developed from over dewatering. As you can see here in the picture, he was just standing on the edge and the ground just sucked him in. The date of the incident was September of 2015. The construction company, the report does not provide any name for the construction company, and I've been trying to research it, but haven't been able to find it. So the scope of the work, it's an upgrade project for a municipal sewer treatment plant in British Columbia in Canada. So the goal was to construct a new lift station, as you can see here in the picture provided. So a lift station is just a cylinder structure to move sewer from a lower elevation to a higher elevation, as you can see. So sewer comes in, the pump pumps the sewer up into a higher elevation. Next slide. So then, before this project was started, two geotech reports were done. Three boreholes were drilled in the first geotech report, and they were drilled about 20 feet below the ground level. The second geotech report was drilled 30 feet below the ground level. So, as shown here in the picture, the report showed right below where the lift station was going to be placed, there was a layer of silt, and then right above it, a layer of sand. And then they found that the groundwater level was located about 7.5 feet from the ground level. So for this project, a steel caisson was used, and it was driven into the ground. Its placement was to prevent groundwater from the side of the job site. So, like the I can't go back. It was to prevent groundwater from the sides of the job site. The silt layer was going to help prevent groundwater from entering from the bottom. So they were expecting the silt to stop the groundwater from the bottom. So the dewatering system was made out of three different components. The dewatering well points. So these were used to extract water before extracting the soil from inside the cage. And then next, the submersion pumps that were inside the steel casing, and then two steel pipes, as shown here, were used to monitor the groundwater levels. So how did this quicksand condition happen? So a worker was checking the submergible pumps and saw that the pumps had almost pumped all the water out from the silt layer. When he took a step back, he was pulled down into the soil, and that's how the quicksand condition was pulling him. Luckily, he was able to grab a metal pipe from the dewatering well point system, and that's how he grabbed himself. Two workers later tied him with a strap to that same pipe, so then rescuers could save him. The worker was saved. So what caused that quicksand condition? So after the investigation, it was found that another aquifer was right beneath that silt layer, and the municipality had done a third report but failed to provide the information to the contractor. So when the caisson was dewatered, the lower aquifer pressure pushed the silt layer and the sand layer, so everything was moving right beneath, which caused the quicksand condition. As you can see here in the picture, everything was flowing into the caisson, and the worker was being pushed down. So, as a project manager engineer, it's always good to have a good communication with the owner. The city had failed to provide that third geotech report, which could have prevented this accident. So therefore, it's our responsibility to always be talking with these with the owners. And here are my references. And thank you.